Alrighty, hello. Oh, hello everybody. Here we are. Here we are today. A little more with exponents, huh? And fractional exponents and negative exponents and stuff like that. So, let's see. This is page 6. I'll do a little bit more with this. And the directions here, rewrite each expression with fractional exponents and no radicals. All right, fractional exponents, no radicals. I'll start with the nice, not too bad one here. How about number 9? 6 over 5 times the square root of x to the 7th, right? If there's no root there, right, with the radical, remember it's implied to be a square root. Square root meaning second root. All right, so what were the directions again? Rewrite that with fractional exponents and no radicals. So I'm gonna make this here 6 over 5, the square root of x to the 7th. We're going to rewrite that, do a reverse power over rule. All right, so it's going to be x to the, the root is the denominator, right, of the fractional exponent. And the power is the numerator, right, of the fractional exponent. So x to the power of 7 over 2. All right, so fractional exponents, no radicals. All right. So you could, like in number 6, make that a positive, or move that to the numerator if you want to. You don't have to here, but if you wanted to take this x to the 7 halves and just, kind of have everything on level ground here, right, you could move that to the numerator, and that would change the sign of the exponent to negative 7 halves. Now, technically, that's not on level ground, if you're kind of thinking about what do I mean by that, not kind of, but like this answer right here, everything's on level ground, you could pull out the 6/5 here in number 9. And make that, this will be more like a level ground answer. X to the negative 7 halves would go off to the side there. So all 3 of those are equivalent. But, honestly, I would probably just leave it like this, But if you want to write it like the other 2 versions there that I wrote, that's fine as well. All right, let's do number 12. That's 10 over 15 there. The 15 is stuck to the square root of x squared minus 25. So you could reduce that if you want. If it was 15 plus square root of x squared minus 25, you would not be able to. So if you want to reduce this, right, 5 goes into both of these guys, right? 5 goes into 10 2 times. 5 goes into 15 3 times. All right. And let's see. Remember with the square root of x squared minus 25, I was talking about this last time. You know, with number whatever it was, number 1, you know, talked about number, or made an example there. You can't take the square root of each term there. All right, with the minus sign. So let me see here. I'm going to write this as 2 over 3. And then the square root of x squared minus 25 is x squared minus 25 to the 1/2 power, right? Once again, you cannot take the square root of that. It is not x minus 5. And, right, you can leave it like that. Going back here, fractional exponents, no radicals, that's what we have. So, you know, once again, if you want to mess around with that a little bit, you can, and, you know, move the x squared minus 25 to the numerator. It would change the sign of the exponent, you know, and much like number 9, if you wanted to rewrite it in those other two versions. Okay. All right, let me do one more on this page, and then we'll see what we got going on with the next page here. Let's do number 14. Number 14 here. Now, square root of x minus 4 cubed root of x, you cannot subtract that, people. Right? They need to be the same, and what I mean by that, you know, is something like, you know, if you had 4 radical x minus 2 radical x, that you could subtract. All right. That would be 2 radical x. You subtract the coefficients and keep the radical. And you don't have that here. So you cannot subtract that. You know, just go ahead and follow the directions here, right? Square root of x, right? Second root of x to the first is x to the 1/2 minus 4 times cube root of x. It's x to the 1/3, right? Minus 4x to the power of 1/3. Plus now 6 over 5 times the 4th root of x. And that's going to be 5x to the 1/4 power, right? Reverse power over root. And once again, you don't have to do anything here with the directions, right? No radicals, fractional exponents. You know, once again, if you wanted to move the x to the 1/4 to the numerator, you could, but you don't have to. All right, so there you go. Answer for 14. Let's see what we got on the next page now. All right, so it looks like the reverse process here of what we just did on page 6. Rewrite each expression as a radical expression with no fractional or negative exponents. You do not have to rationalize the denominator. So we're going backwards here. We're writing our answers now with no fractional or negative exponents, right? What were we given here? We were given radicals, right? and how to write our answer with fractional exponents. Here, no fractional or negative exponents, all right? So yeah, it's just the reverse process now. So here we're taking the fractional exponent and writing it as a radical, people. You know, that's all. Right? It's just the reverse. So number 15 here, guys, this is 2 times x to the 1/3, right? 2x to the 1/3 power is 2 times x to the 1/3 power. Okay. So that's 2 to the first. 2 is not being raised to the 1/3 power there. Right. If 2 was being raised to the 1/3 power, that would be number 16 actually, right? You see, you would have that whole, the base, that whole quantity 2x. All right, so that's 2 to the first there in number 15. All right. Times x to the 1/3. All right, so we gotta do a power over root on this guy, right? I'm gonna make that the cube root of x. So this is going to be 2 times the 3rd root, or cube root of x to the 1st, which you can, just write as the cube root of x. And there you go, right? No fractional exponents. All right, or negative exponents. That's your answer. All right, now, like I said, number 16 here, we'll do that one next. Now the 2 is being raised to the 1/3 power because of the parentheses. 2 is to the 1/3, x is being raised to the 1/3. So if you want to expand that, you can. You don't necessarily have to, right? Here, 2 is to the 1/3, x is to the 1/3. Or you can, I would just leave it like it is, like it was given to us, but, just saying. So another reverse, right, of what we were doing on page 6. This is going to be the cube root of 2x to the 1st. Like I said, you don't need the 1 there. If you want to put it there in 15. If it's a number other than 1, then, you have to do it. But, not when it is 1. All right, so that's 16. 17 is, this is 5 times x to the negative 3/2. Again, once again, that 5 is to the 1st power. So what do they want? No fractional or negative exponents. All right, so this is a double action deal. All right, we're gonna have to make that negative exponent here a positive, right? I'll move that downstairs. You could change it to a radical first, right? We said that the order doesn't matter. So this would be the 5 is still in the numerator over x now to the 3/2 power. The negative exponent changes, right, to a positive. And then x to the 3/2 here. We're going to now make that a radical, right? Power over root. So this is going to be 5 over the square root of x cubed. The 3 can be inside with the x, or you can have it on the outside there. It does not matter. All right, that is your answer for number 17, people. Okay. Number 18 is now that both the 6 and the x are being raised to the negative 5/3 power, okay? So, if you want to do power over root first, like I was saying there in the previous question, you can. All right, now remember the root has to be positive, so that's going to be the third root of 6x to the power of negative 5. All right. And then you want to make that a positive exponent. We're going to take all of this and move it to the denominator. Doing so, we'll change the sign of the exponent. Is the third root of 6x here. Well, actually, that's going to be in the denominator, so let me see here, give myself some space. All right, so that's going to go to the denominator. All right, so we'll have the third root of 6x here to the power of 5. And then we got to put something in the numerator, people, right? If there's nothing left over to put in the numerator, we got to put something down there and not a 0, right? We're going to put a 1. So 1 over the cube root of 6x to the 5th power. Let me rewrite that a little nicer. 1 over the cube root of 6x, that whole quantity there, to the power of 5. There you go. That's a little better. All right, is your answer there for number 18? People, okay? Not too bad, eh? All right, so on the other side, I'll do some more of these guys here on page 7, and then, we'll see what else we got going on after this. Doesn't look too bad so far. All right.